All right, so today we're going to talk about the applications of logarithms. So here are some general formulas. You will be given these formulas on your test. Now, there are other formulas that exist. However, these are the ones we're going to focus on for today. So even though they're different formulas, all of the setups are kind of the same. So here, these are your ending amounts. So all of these values here are your ending quantities. All of our next values are your initial or your starting amount. These R's and the K, these are your rates. You want to make sure they're written as a decimal. And then T is time. Let me erase these so we can see our formulas. So we're going to use exponential growth or exponential decay if something is getting bigger. Growth, smaller would be decay. Investment, if it says the word invest. Now, the only time we're really going to be using these half-life formulas is if it's talking about, if it says half-life, if it talks about some kind of element or fossils. Our big element that we talk about generally is carbon-14. All right, so Alex invests $200 in an account that has 6% annual growth. To the nearest year, when will the investment be worth $3,600? So we're going to use our investment formula. So A equals P times 1 plus R to the T. So let's define what our variables are. A in this equation is our our ending amount. We are ending with 3,600. P is our starting amount. We are starting with 200. R is our rate as a decimal. So with the percent, we move the decimal sign over twice. So this is 0.06. And T is what we're looking for. So then we'll go ahead and plug these into our equation. So 3,600 equals 200. 1 plus 0.06 to the T. So the first thing I'm going to do is divide each side by 200, because we cannot distribute this 200 here because of the exponent. So to get rid of the 200, we'll divide each side by 200. So 18 equals 1.06 to the T. I went ahead and added that 1 plus 1.0 or 0.06. Now here, what I like to do is I switch the sides. So 1.06 to the T equals 18. And the reason I do this is because our next step to get that exponent out is to write it in log form. And it's easier to write it in log form when your exponent is on the left. So when I write this in log form, we write the word log. The base of our exponent is the base of our log. So this is log base 1.06. And then I switch the next two. So of 18 equals T. So I'm going to use the change of base formula on this next part, so that I can stick it in my calculator. So using the change of base, we'd get log of 18 divided by log of 1.06. And then we'd stick this in our calculator. So we get 49.604. 49. And it says to the nearest year, so T would equal 50 years. So take about 50 years for it to grow. All right, so number 2, a piece of machinery depreciates, which means it is getting cheaper, or the value of it is going down. So here we're going to use our exponential decay formula. So y equals a 1 minus r to the t. So we'll set up our problem. Y is our ending amount, so it's ending at $10,000. A is our starting amount, how much it's starting with, so 250,000. R is our rate as a decimal, so this is 0.12. And T is what we're looking for. So what I'd like you to do is pause the video and see if you can get this one. So pause it, I gave you the values, plug them in, and then solve the equation. All right, go ahead and check your answers. So the first thing we did is plug everything in. Divide each side by 2,500. So I got 0.4. 1 minus 0.12 is 0.88. I just switched the sides of the equation so that I could write it in log form. So 0.88 is my base. I switched the next two. I used the change of base formula to let me say log of 0.4 divided by log of 0.88 equals t, and then I stuck it in my calculator. All right, so go ahead and read number 3. Pause the video if you need to. All right, so we're talking about inflation. So inflation means that it's getting more expensive, so we're using our exponential growth formula. So y is our ending amount. It's ending at 12,500. A is our starting amount. It's starting at 8,400. R is your rate as a decimal. So even though there's a decimal here, to make it into, get rid of the percent, we move it over twice. So this would be 0.051. And T is what we're looking for. So we'll plug these values in. And then solve. Now, one thing that happens is when I divide by 8,400 here, I'm getting an ugly decimal, so I'm going to leave it as a fraction. I'm going to leave it as 125 over 84 equals 1.051 to the t. So then I'll switch each side. So 1.051 to the t equals 125 over 84. And then I'll write it in log form. So log base 1.051 of 125 over 84 equals t. We'll then do the change of base. So the log of 125 over 84 divided by the log of 1.051 equals t. Stick this in our calculator, and we get 7.991 equals t. All right, so pause the video and read number 4.
I was about to start writing slow.
All right, so one key that we're noticing is it's talking about carbon 14, so that's a key that we're going to be using our half-life formula. And really it doesn't matter if we use growth or decay, it's just going to change the t value we get. I'm going to recommend that you always use decay, but it really doesn't matter. So here we don't really have too much information because we need our y, our a, our k, and our t. And t is what we're looking for. K, it tells us to use 0.0012. Now, it doesn't tell us our ending amount or our starting amount. It tells us that our ending amount is 1/4 of our starting amount. So I'm going to leave my starting amount as A, and my ending amount is going to be 1/4 A. So we'll go ahead and plug everything in. So 1/4 A equals A e to the negative 0.00012 t. So we'll start off by dividing each side by A. So 1/4 equals e to the negative 0.00012 t. Now to get rid of the e, we take the natural log of each side. So the natural log of 1/4 equals negative 0.00012 t. We'll divide each side by negative 0.00012. Which gives us that t equals 11552.453.
What was that?
All right, our last one, laboratory cultures increase, so we're using our exponential growth equation. So here our ending amount is 195, our starting amount is 10, our rate we don't know, but our time is 5. So we'll plug this in. So we'll start this off the same way. We'll divide each side by 10. Now, to get rid of the 5th power, we're going to take the 5th root of each side. So we take the 5th root of each side, so that the right side will just be 1 plus r, and the left side is 1.811. Subtract 1 from each side, so we get 0.811 equals r, so r is 81.1%.